These are the three most missed questions from the functions GVC test in this class. Number 2 was the most missed question, then number 11, and then number 5. We'll go through each one and you can add them to your notes. On number 2, we have to decide whether each relation in the graph is a function. Well, a function means that every input gets one output. Remember, input is x, so we're going to check all of the x values. If we look at the points in the first relation, we want to check each x value. So where x is -2, there's only one point, or one output. Then we can check where x is 0, there's only one point. Where x is 2, only one point, and so on. Since at each x value there's only one point, that means it is a function. It's called the vertical line test. If we draw a straight up and down line, and it touches more than once, then it's not a function. But if every time we draw a straight up and down line, it only touches one place at a time, then that is a function. The one on the bottom left is kind of strange. We can check these places, and there's one point where it looks like it touches top and bottom, but the bottom has an empty circle. An empty circle means that point is not included, so it doesn't count as touching twice. That's an inequality. It means like x is greater than 2, where x can be anything bigger than 2, but not actually 2, since 2 is not bigger than itself. Since the empty circle doesn't count, that doesn't count as touching twice, and we can check the rest of it. Since it never touched more than one place, except where one's empty and doesn't matter, then that is a function. The one in the middle touches top and bottom, and so is not a function, and the last one, when it looks at the -2 for x, has a point on the top and the bottom, which would be two outputs, meaning it's not a function. On number 11, we have to decide which graph matches each story the best. On part A, Jane is hiking towards her campsite. We want to keep track of the distance. As she goes towards her campsite, that distance is going to be decreasing since she's getting closer. When she saw a snake and ran away, the distance is going to increase because she's running away from camp. And when she sits down to rest, the distance would be constant or the same since she's not getting any closer or farther away. So we're going to look for a graph that's first going down, going up, and then staying the same. On part B, Ravi's jogging and we're tracking his speed. As he goes faster and faster, his speed is increasing or going up. When he stays at the constant speed or the same speed for several minutes, that speed's going to be the same. And when he slows down to a stop, the speed should decrease to 0. So we want to look for a graph that's first going up, then staying the same, and then going down to 0. The last problem, number 5, wants us to determine whether each equation is linear, which means it makes a straight line when you graph it. Obviously, we can graph all of these and see whether or not they're a straight line, but there is a trick. Anytime there's an exponent in our function, it's going to not be linear because those make the lines curve. We can graph this using the Desmos.com graphing calculator just to check if you're not sure. With the last two, these ones don't have any exponents, and if we graph them, they make straight lines, so they are linear.